So now we are going to understand the one of the most concepts in AI, explainable AI, using a real world healthcare case study, right? So before that we have to see what is what in the fourth unit. Now we are seeing this. Take a one case study example. I will explain all those things in one case studies, right? So explainable AI using the real world healthcare case study. So imagine a situation, a patient comes to a hospital and an AI system look at the chest x-ray and says high risk of pneumonia. Okay, I'll show you. Yeah, high risk of pneumonia. Now the big question is, can we trust it? Can we trust it? So doctors will never accept a decision blindly because they are blindly. Uh, okay, they need to know why did the AI say this? Where did it look in the X-ray? What features influence the decision? Okay, why did the AI say this? Where did it look it in the X-ray? What features influence the decision? So this is where the explainable AI comes into the picture. Clear? So in this case study, the AI system predict the pneumonia from chest x-rays. So let's understand the stakeholders. Doctor need a justification, patient need the clarity, hospital need the reliability, right? Doctor need the justification, patient need the clarity, hospital need the reliability. So the goal is simple. Make a AI decision transparent and trustworthy. Okay. So the key question is, can AI explain what it sees and why it made a decision? Okay. Where it look and what influenced the decision, right? This is a visual diagram of pneumonia, chest x-rays. So now let us move into the first important concept, attention. The AI does not blindly look at the whole image equally. Instead, it focuses on important region just like a doctor. For example, it focuses on lung areas. It ignores the background like labels or borders. What did the model detect? Lower lung opacity, right lung inflammation. So why this is important? Because the doctor can verify, yes, these are clinically relevant areas. So this builds the trust. And real world analogy, think of reading a newspaper. You don't read every word equally. You're focused on the headlines. AI does the same, right? So the model gave the higher weight, right? So the doctor confirmed clinically relevant areas. The outcome, the increased the doctor confidence, faster diagnosis. Clear? Hope you understood the first concept of attention mechanism. This is a visual diagram. Next concept, modular explainability. So instead of one big complex model, AI is divided into modules. Lung detection, module 1, module 2, infection pattern analysis, which means infection analysis, module 3, severity scoring. Okay, three models. So instead of using one big complex model, we have to use three models. So why is this useful? If something goes wrong, you can identify exactly which model failed. Suppose infection analysis model 2 failed, we can identify easily this is happened at the model 2. Okay, so that's what we need, a modular networks. Okay, if a severity score is wrong but the deduction is correct, the error is isolated. So I have to say, instead of very simple, think of a car. Engine problem not equal to brake problem. Your diagnosed parts are separately. So the main benefits of using the modular networks are easy debugging, easier approval is hospitals, right? This is a visual diagram of that. Now let us understand what feature AI identifies. So the model detects the patchy white regions, texture irregularity, density changes. Doctors compare these medical guidelines. Result, the AI features match the human diagnosis. So this is powerful because the AI is not just guessing. It is learning medically meaningful pattern. So real-time example, the doctors look for a cloudy areas in lungs. The AI does the same. So how the doctor used it, it compared the AI identified features with the medical guidelines. It found a strong alignment too, right? One major problem with AI is complexity. So instead of showing question, equations, AI gives the simple explanations like prediction based on the opacity in lower right lung. Why is this important? Because the patient can understand their conditions and junior doctors can learn. Okay, it is mainly used for the junior doctors and patients. What is the impact of the XAA? Reduces the fear of AA. Okay, then make AA is user friendly. This is a visual diagram. Now let us go into the deeper how the AI learns internally. So different CNN layers learn the different things. Early layers edges and shapes, middle layers textures, deep layers infection parts. So this shows that the AI learning structure. So doctor insight, this AI is learning meaningful and medical features. So this increases the confidence in training quality. So the outcome is trust the model in the training quality. This is the visual diagram. Now come one of the most powerful grad come. It produces the heat map. So red areas are important regions. Blue areas are ignored regions. In our case, the red highlighted appears on infected lung areas. Wait, I show you the picture. Okay, red highlight appears on infected lung area. So this act like a second opinion for doctors. The benefits of visual validations, faster decisions. Next, we check how the neurons behave. Findings: strong activation for cloudy lung regions. Response to disease patterns. The robustness testing, which means the slide blur, no major change. And the brightness change, stable. Lung region change, prediction changes. So the conclusion, model is stable, not sensitivity to noise. So final thought, the AI is alone is powerful, but AI plus explainability is a reliable AI. Think about this every day. Okay, I'll give you one another real time example. Think about this every day. You open Instagram and somehow it already knows what you like. You scroll for 5 minutes and suddenly all of these reels are exactly matching your interest. So maybe coding, maybe memes, maybe our fitness or travels. Now the question is, how is it doing that? And one more importantly, can it explain why it is showing you that the content? That's where explainable AI comes in. Normally, AI just shows the results, but explainable AI tells you the reason behind it. For example, when the Instagram shows you a reel behind the scene, it is using something like an attention mechanism. It is not looking at everything you do equally. It focuses on what you spend more time on. Like if you pause on fitness video or replay a funny reel, it gives more importance to that. That's exactly like the AI is medical case, focusing only on lung regions. Here, Instagram focuses only on your interest regions. If Instagram actually explain it, it would say something like, we are showing this because you watched similar videos for 10 seconds. That is explainability in a simple way. Clear? Now take a Flipkart. So when you search for a product, say a mobile phone, it shows the recommendations like a top picks for you are frequently bought together. This is not a random. The Flipkart's AI is divided into modules. One module track your search history. Another analyzes your budget range. Another compare your ratings. This is similar to modular explainability. If something goes wrong, like a wrong recommendations, the engineers can check which part failed. Was it price filter or preference model? This is exactly how the complex AA systems are handled in real life. Now think about the feature identifications. When Flipkart recommend a product, it is actually identifying features about your behavior, like your preferred low price and high ratings or specific brands. It does not just say you like phones. It understands deeper patterns. Like you prefer the budget phones under 15K or you prefer the budget phones under 8K with a good battery. Just like in the medical example where AI identifies lung patterns. Here AI identify user behavior patterns. Let's make it even simpler. When you see recommended for you, imagine if the system clearly told you you are seeing this because you searched for shoes yesterday and you viewed similar items. That is a human readable explanation. So instead of showing the complex AI logic, it gives a simpler sentence you can understand. This is already partially happening in the platform, like a YouTube where it says because you watched. That's a perfect real world example of explainable AI. Now coming to visualization like a GradCam in medical AI. In apps like Instagram or YouTube, you don't see heat maps, but internally the system knows the exactly what part of your behavior is triggered. The recommendation. If it were visualized, it would highlight the things like watch time or likes or shares as a hot areas that's similar to showing red zones on X-ray. It is a just on social media. They don't show it visually, but the concept is same. Like next, neuron activation is like how strongly the system react to your action. For example, if you suddenly watch 10 videos about the coding, the system quickly adapt and start the flooding your feed with the programming content. So that means certain interest neurons got highly activated. But if you accidentally watches one random video, it does not completely change your feed. So that show the system is stable and not overacting, similar to the robustness in AI model. So even robustness testing happens in real life. Suppose you accidentally click on the one product on Flipkart or watch one random reel. This system should not immediately change your entire recommendation. So good AI systems are designed to ignore small noise and respond only to consistent behavior. So that's exactly like a testing AI models with brightness or blur, checking if they remain stable. So when you look at all this example together, you realize that explainable AI is already around you in daily life. So whether it is Instagram deciding your feed, Flipkart suggesting the products, or YouTube recommending the videos, all the systems are using similar concept. Focusing on important data, breaking the decision into parts, identifying patterns, and sometimes even explaining their choices. The only differences in critical areas like healthcare, explanation is mandatory. But in the apps like Instagram, it is optional and often hidden. The main takeaway is AI is everywhere. But when the AI explains itself, it becomes more trustworthy. Without explanation, it feels like a magic. With explanation, it feels like a logic. And that is the real goal of explainable AI. So not just give to answer, but to make humans understand why those answers are in given. Clear? So let's summarize the entire case study. AI became the explainable, doctors started trusting it, diagnosis became faster. So explainability converts the AI from a black box into trusted clinical partner. The real world values are trust, transparency and adoption. So the final thought is AI alone is a powerful, but AI plus explainability equal to reliable AI. Thank you.